Good afternoon, everyone. Good afternoon, sir. Myself, M. Manishankar Nayak from VLSA third year, and I'm here to present upon the topic NOMA, non-orthogonal multiple access. So, it is a technique where multiple users can share the same network at the same time and in the same frequency also. Instead of giving separate resources older systems like OMA, NOMA allows users to share resources using different power levels. And the core benefits of NOMA: improved spectral efficiency. When the efficiency is high, we can send more data in the same bandwidth also. Massive connectivity. In the massive connectivity, it supports a significantly larger number of users than the older methods like OMM, which is crucial for the IoT devices. And low transmission rate, lower the delay, and which leads to the faster the communication, which also enables the in the NOMA it enables grant free uplink, which means in devices, normally in networks, a device must ask permission from the base station before sending the data, which usually in general takes some extra time for asking the permissions and granting the permissions, which is significantly leads to the delay. But whereas in the grant free uplink, the device does not ask permission from the base station or some other networks. It sends the data directly. uh, by sending the data directly, which leads to very faster communication, and it is good for IoT devices such as sensors, smart devices, and also reduces the signaling steps, and also reduces signal steps. How NOMA works? How NOMA works? Uh, NOMA works by sending signals in different ways and then separates them. At the receiver, NOMA usually sends the signals in multiple ways but separating them at the signal. So in the power domain, it sends signals to the weaker and stronger users in a different power levels, whereas weaker users get more power and stronger users get less power, which leads to the balance of the signal. In the code domain, multiple users get the same frequency, but each user is given a unique code, so the receiver can separate users using these codes. For example, we can take three people are talking at the same time, but each speaks a different language. You can but we can understand only but you can understand each person by identifying their language. So in simple, codes are equal to languages. So why it is used, where it is used: allows many users at the same time, improving efficiency, no need to separate by time and frequency. No, the 5G challenges and NOMA. So in the 4G, there are users limited because each user needs separate resources, but whereas in case of 5G needs to connect many devices, so NOMA solves this 4G problem. Limited users, 5G needs massive connectivity, NOMA solution. Users share same resources. In simple, NOMA removes user limit and increases network capacity. The connectivity bottleneck. The current limit. Traditionally, OMI limits users, counts, and available orthogonal resources, the time and frequency. Key practical factors. The key practical factors are: so in real world implementation, NOMA depends on some important factors like power allocation, signaling, overhead, and SIC errors, and also user pairing. NOMA still performs even when users are moving faster. Uh, Through this, it gives around 30 to 40% higher throughput compared to the traditional OMI systems like 4Gs. Even with simple methods like fixing power allocation, most of the benefits of NOMA can still be achieved. So, challenges and opportunities. Challenges. NOMA has some challenges like high receiver complexity due to SIC. It also depends on accuracy of the signal information for proper performance and the opportunities. NOMA NOMA enables massive connectivity. NOMA enables massive IoT by connecting billions of devices. It also supports ultra reliable low latency URLLC, ultra reliable low latency, which is important for automation and critical systems. So in simple one line we can say that NOMA has challenges, but its benefits for IoT and low latency communication makes it very powerful. So a key enabler for 5G and beyond. Unlike older methods like OMA, in the OMA that gives each users their own lane, but as in the NOMA, it lets multiple users share the same frequency and time. So the main advantage of it is it's like a carpool for a data. It fits more users into the same resource, making 5G much faster and much efficient. When we look at the graph, it shows two lines determining OMA and NOMA. The orange or yellowish one determines the OMA, whereas the blue one named for, known as NOMA. So there are three things to notice. In the first of all, the x and y axes. The bottom line, which is the x-axis, represents SNR, signals to noise ratio. It represents the signal quality. The further we move to the right, the stronger and the clearer the signal becomes. And the left side, the y-axis, represents how much data we can actually send. Basically, in simple, we can say that the speed of the data. And secondly, the gap between the gains, the gap between the two lines, which is NOMA and OMA. Noticing by looking at the gap, we can notice that the signal gets better while moving to the right. The blue line climbs much faster and higher than the yellow line, which is OMA. Here NOMA climbs much faster than the yellow line. So the gap between the lines represents the extra capacity we get by using NOMA, non-orthogonal multiple access. Basically, the graph proves uh, that for the exact amount of power and frequency, NOMA can carry significantly more data than the traditional methods. Yeah. So key principles: power domain and power domain NOMA. So superposition coding SC. The base station sends a mixed signal, whereas it gives much power to the users with bad signal who are far away, you can say, and less power to the users with good signal who are nearer to the base station, as we spoke about this earlier. And the SIC, successive interference cancellation. So this is like a magic decoder. So the nearby users receive the big mixed signal. It identifies the far user's data, subtracts it like noise, and find out its own message. New techniques like RIS, reconfigurable intelligent surface, RIS. What is RIS? So it is a small mirror for radio waves. It's a surface that reflects signals in specific direction to help to reach the user. The combination. So what would be like the combination of RIS and NOMA? So the combination, when you combine RIS plus NOMA, we can boost the weakest user, making the whole network much more reliable and efficient. Challenges and variations. So implementing hurdles. So the hardest part is receivers need to be smarter and more powerful to do the decoding, at the SIC end, which can drain the battery much faster than normally. So the types of NOMA, we mainly talk about the power domain, which is more like a varying power, but there are also a code domain which usually it does math codes to separate users. A promising future. So NOMA is a disruptive tech. NOMA is a fundamental and disruptive technology. It matters a lot in the current generation as it is the key to connecting millions of IoT devices and making 6G a reality. It moves making 6G a reality, and it moves us from one lane roads to multiple level highways, for example, we can say. So that's it. Thank you so much. Thank you, sir.